So now we're going to take a look at on-click event handling, because once we understand the basic framework for event handling under Java with Android, we can then pretty much handle all other event types as well, like a timer tick. The basic concept is the same. So an on-click event may get triggered when we click on a button, for example. So the first thing that we'll do is we'll modify the content of the user interface. So in main.xml, we can add a button, and just like under HTML, there is a markup language tag called button under the Android markup language. Now, r.java then is going to reflect the fact that we've added this object, and we could give the object an ID so that we can reference it from the Java code. Basically, anytime that the Java code needs to programmatically handle content in the user interface, then it needs to have both an ID for the object, and that ID needs to be bridged with an integer value as described in r.java. So activity.java is where we're going to place the code that responds to clicking on a button. And the way that we do this is that we set up an on-click event handler. So if we were building an HTML website and we were using JavaScript to respond to a click event, the concept would be the same here. We would have in HTML a button that had an on-click property that said go to a function or evaluate this JavaScript expression and do a thing. But here what we're going to do is to set up a reference to the name of a Java function that gets called in response to clicking on this button. Now, within the context of the Android markup language with XML, there are a couple things to remember. We've already taken a look at the linear layout, and to reinforce this point that the values for the properties of the height and also for the width are critical to set as a good habit. It's a good rule of thumb to always set these values, because there will be times when the application will crash on certain elements that must have this. So even though there's one or two that don't require it, it's better to specify it at all times. So the orientation for the linear layout is going to affect the location of the button. So for example, if we had the linear layout set up to portrait or landscape, that would determine whether or not the button would fall under the current text view or to the right of the current text view. So we're going to utilize the behavior of the linear layout to decide whether or not the button gets aligned to the bottom or to the right. And we're going to keep in mind that the importance of always setting the height and the width, even though it's not required always, will help us not crash the application. So now let's take a look at the button tag that we can use to bring in a button onto the screen. One thing to keep in mind is that the development environment for Microsoft Visual Studio and also the interface builder for the Objective-C for the Apple is more robust and also more mature than the current version of the Eclipse user interface builder. We're basically going to use the concepts of building a website in HTML to just describe what we want in XML. It's a very friendly language, and then just to test it and see what it looks like. So we have this button that we're going to bring into the user interface using the button tag, and we'll set properties: the height, the width, and also the text that the user sees on the face of the button. Now, once we've set these things, one of the new features of the Android SDK with Gingerbread is that we have this on-click property that lets us bind the name of the Java function without actually writing Java code to set the on-click listener. So again, we're going to remember to specify the height and the width so that we don't crash the application. So when we talk about on-click event handling, there are a couple of different ways that we could specify the binding between the event and the Java class. So Java listener classes are set up by configuring this property, set on-click listener. So we take the on-click listener, we pass in a reference to this, saying that this class is capable of responding to a click event. But now in the current versions of the Android SDK, there's a shortcut using the Android markup XML. We can add this property or this attribute called onClick and simply specify the name of the Java function in the same way that we have in the past configured the JavaScript function name for a HTML button. So basically they now share the same concept, the same framework under the Android markup language and also HTML. So the next step in this example is to bring in a button into the user interface. Remember that currently the user interface has this text view. We're going to add a button below all the content, and because we're using a linear layout, it will automatically drop that below the existing content. Working our way then back into main.xml, we're looking at a text view. And below that, we're going to add a button. So the vertical orientation of the linear layout is telling us basically that the button will not go to the right side, but instead it will go below at the bottom of the existing content. So we're going to add a button. And just like in HTML, we could just say button. And then Android, we're going to borrow the basic concepts for the width and the height that are going to look just like on the text view. So we could say layout width. And then also the height. The text content. And what to do in response to clicking on the button. So the two attributes that are unique to the button, the text value displaying the content of the button, the on-click event, the function, what to do in response to the button, that now needs to be defined in the activity.java file. So let's save this, and we're going to work our way up into the Java file, and we want to add a function. So we could say something like this: public void my Java function, and the parameters that come in represent the object that got clicked. Now we'll fix this in just a second. There are a couple of red X's that we'll address in just a moment. But the first thing is to double check that my Java function is also the name my Java function that the markup language is going to look for. We don't want a spelling error. We don't want to have a mismatch on the binding of that name. So now we can bring in a couple of things. So just under Java syntax, the curly braces define the content of the function. Also, the parameter, the argument that's passed, is a view. So the definition of a view is undefined by default. So under Eclipse, we hover the cursor or the mouse over that red squiggly, and we get a suggestion to import this object called a view. So Android.view.view fixes this problem, and we may or may not actually need to reference that view, the generic button object that gets clicked on, in order to respond to it. So, for example, we could send an entry into the debug log file. We could say something like this: log.i, send general information about the current state of my Java function. And typically we'll say something like begin and end to confirm at runtime that the code worked. So here in the middle, we'll do something useful. And we need to also address the problem here. Red squigglies on the word log. So what does that mean? Basically the same thing. We need to bring in the definition of a log file. So android.util.log is now part of the reference on the import. And at runtime, we're going to be able to look at that. That's called logcat. So let's save this content. Let's open up that Android window called logcat. It's found here under Android, logcat. And we're down at the bottom. We can actually erase the content, start with a clean page. And really all we need to know is the message that comes out and maybe the tag itself. Remember, there are two arguments on the log. So we're seeing the log file activity right now. Stuff's coming through the Eclipse development environment, talking to the virtual device. And we'll go back to our project here. And let's go ahead and run it. Okay, so here we go. We see the button. The message says click here. We see the width of the button is filling the content of the parent. And also, here in the debug log file, we want to watch what happens, and we're going to look for the begin and end message. And that looks perfect. So my Java function is getting called in response to this button. It's sending out the message begin and end, representing that it's correctly binding to this event for the onClick event. So now let's take a look at how we can write additional code inside the click event that modifies the content of an object that's back in the user interface. And the way that we do that is we start by looking at the user interface. We see a reference to a text view. Now, currently the problem is that the text view here is an island. It's isolated from all Java code. And let's go ahead and space this out so that we can see the reference to the parent-child relationship of the button under the linear layout, and also the text view is under the linear layout. So at runtime, the button is not something that we need to handle to from Java, but let's say that, for example, we wanted to modify the content of the text view. We want to change this property text to say something other than the content that's currently coming from strings.xml. So remember that the hello parameter in strings.xml is the default startup value for this text object. But we want to change it at runtime, and we'd like to change it via the code here inside of Java, inside this myJava function that's already getting called. And we want to replace this do something useful with modifying the content of that text that we see on the screen. So here's what has to happen. If we look at r.java and we look through r. and all this stuff, we don't see any reference to an integer for that text view. So what we have to do is to go back into main.xml and add a reference to an ID for this object. And the way that works is we say Android ID is equal to, and this is where the magic comes in. The reference here is to an ID, but we'd like it to be created. So we'll say plus ID slash, and then we'll call it something, my text view. Now, the reference to the plus sign here is really fascinating because under r.java, if we save this file, under r.java, what we're looking for is this reference now that auto-magically got created. So there's a reference to 7F050, that's a hexadecimal representation of an integer, and that's what we're going to reference from the code under Java. Now, we could either A, remember this integer by memory, or B, we can reference it via the class syntax like an enumeration. r.id.myTextView is another way to point to that same integer. So what do we mean by that? If we go back into the Java code and we make a reference to the text view, we can say something like this, a text view called my text view is equal to something. Now, first of all, the definition of a text view will import. So that's textview.widget.android. And the next thing that we're going to do is to typecast. Now, if we were referencing in HTML, one of the objects within the document, we can reference getElement by ID. And HTML would return a handle to the JavaScript engine. And that's exactly what we want to do, but using a different syntax. So what we want to do is to return a text view from a function call. So this dot find view by ID, r dot ID dot, and there it is, my text view. So what this does is to bring back a pointer in memory to the object, and here's what it does. Using that integer value, find a reference to an object in this activity. And because view is an abstract object type, we want to actually cast it specifically into a text view so that memory space is addressed properly. So we're creating this variable, my text view, of this data type text view, and we're getting a yellow squiggly under Eclipse, which says that the code is fine, there are no bugs, but it's wasting memory because there is no reference to that particular object yet. But we will reference it next. So we'll say my text view dot, and we'll set the text. So this time around, when we click on the button and we invoke the function, myJava function, First, we'll see the output into the log file, begin. Then we're going to see the content change inside the text view. And that'll be wrapped up by the log file seeing the message that says end. Now, generally, the content of a text view, we don't change more than once in the application without just destroying it and creating a new one. It's not really optimized to be updated frequently. We might use a different object for something like that, like an edit text. So just keep in the back of your mind that a text view under Android does not behave the same way as a label does under Visual Studio. So let's try this out. We'll save the content. We'll go ahead and launch this into the emulator. We'll click on the button. We could watch the content of the log file also to make sure that it still works. So two things happen. We see the content here change. My custom message has just replaced the content from the config file. And also, in addition to the content changing here in the config file, we see the output into the log file that references the beginning and ending point of the runtime of that function.